Hi guys, I'm Sanket. I work as senior machine learning engineer at Spotify. And yeah, I have an interesting coffee routine. So I love lattes, okay? So I used to be hitting all these different coffee shops in New York City, trying to find the best one. But then I'm like, after pandemic, I was like, this is just not convenient to do. So I got this coffee machine that I brew my own espresso, grind my own beans and pull a shot and stuff. So it's a lot of fun. I've been learning a lot about espressos, and there are a lot of connoisseurs out there, but yeah, learning a lot on that. Fun stuff.
Welcome back to the MLOps Community Podcast. I am your host, Demetrios, and today is a very special one for me because I am such a deep and dedicated Spotify user. We get to talk with Sanket all about the recommendation systems within Spotify and how they've built that out so that various teams can leverage the embedding store that they have. I was fascinated by the different problems and challenges he talked about, especially when it comes to evaluating and re-ranking and what their system looks like. There were some cool takeaways that I had from here. He broke down what the difference is between the vector store and the feature store and what kind of requirements are on each of these. He also talked to me about how me as a person who is using Spotify has an identity, or I have a vector number attached to me, and how they're constantly updating that. And for him, one thing that is very important is how they can continuously update that and make sure that the embedding and the place that I live in vector space is the freshest and most up-to-date as possible without blowing up the system. Because you can imagine, he said on here, there's 600 million monthly active users on Spotify. If you're constantly fine-tuning these embeddings and you are churning them out for each user, you really have to think about how much is too much. And so he broke down those problems. I had a wonderful time talking with my man Sanket, and it turns out that he's really into coffee like I am. Let's get into it. And if you haven't got your tickets to the conference, I would get it now because we're almost selling out. All right, man, let's start with this. You just told me a viciously hot take that I cannot let go too far from my brain before we get started. RecSys are RAGs. Break that down. Why do you think that?
Got it. Okay. Sure. Let's okay, we're going right into the system then, okay, right? So the reason I think recommender systems have a lot of parallels to RAGs is because of this thing called vector database, right? And I mean, it's a fancy word that we are not talking about, but these so-called embeddings and nearest neighbor lookups have been around for a long time, actually, right? It's just being applied to text and NLP now. But let me give an example, okay? And then we can see how it relates back to RAGs. Say you're listening to a song on Spotify and you want to know what are the 10 most similar songs to that one, right? So let's say it's Bad Habits by Ed Sheeran, right? So now you want to know what are the 10 songs closest to Bad Habits, right? So how a human might do it is the human might like go into other songs of Ed Sheeran. It might like look at pop genre and do something like that, right? But how would you do that at scale, right? Like we don't have humans sitting, right? We have algorithms. So how would you do that, right? And that's where kind of vector databases come in, right? So we have an embedding for Bad Habits, or vector, whatever you want to call it, vector or embedding, which is just a series of numbers. And we do approximate...
But it's off of the... Sorry, hold on. With the embedding, this is what I've always been curious to know is it's off of a description of the song, or it's off of like all of the metadata, like the tempo, and if he's singing in falsetto, and so it's very much things that are describing the song, or it's off of the actual song itself?
It's a song itself, mostly. I mean, there are other aspects to it, but mostly it's kind of like the spectrogram analysis of the song. So as you said, like the tempo, the valence, the instrumentalness, the pitch, like all of those kind of features. And then you add in kind of the collaborative aspect, which is like which people put the songs together in a playlist, right? So it's kind of like playlist co-occurrence. So it's a combination of those two things which kind of builds the embedding. It's a massive system we can get into, but the end output is an embedding, right? It's an embedding. So we uniquely represent each track on Spotify with an embedding. So that embedding model is a black box for now, right? We can go dig into that, but it outputs an embedding, right? And then you load all of these embeddings in an index, right, which we now call vector database, right? And basically now what you do is you do nearest neighbor lookups on that embedding. You get back like 100 or 200 items back, right? That's candidate generation, right? And then you do ranking, right? And this is very similar to what RAGs do, right? Like they do,
Yes.
they retrieve like different documents with metadata and so on. And then they might like rank them based on if it's a New York Times article, it's higher. Like, that's the kind of a shenanigan we do with RAGs, right? And it's very similar here, right? Like you get back like these 200 songs and you're like, okay, so which one are you likely to listen to next, right? And so on. So like you kind of do this personalization and like user understanding thing. And then you rank based on a model. And you get back those 10 songs basically. So that's kind of the approach. At least the retrieval augmented aspect is very much similar. The only thing I guess missing between RAG and RecSys is the generative aspect, right? Like you don't generate back like a paragraph like explaining why say Shivers is similar to Bad Habits, right? Like, oh, they are sung by the same artist. They are like, so we don't do that. Like you just get the output basically. So that's kind of how I see RAGs and RecSys kind of together.
But how about when you're evaluating the RecSys? That's a whole different can of worms too, or do you feel like there are parallels there? Like if it's actually working, how you score that, how you get ground truth, what the golden data set is.
Yeah, I think evals are a little bit same and different, right? And I think similarities are in the sense of all those ranking metrics like NDCG and MRR and like AUC, ROC, depending on like how you set up the problem, right? So those metrics are like classic. Like, I mean, all of ML uses that. The differences, I think, lie in kind of how we do text matching. So I see in RAGs, like they do matching of like exact texts and like tokens and like blue score and rouge and things like that. Over here, like because we're not generating text, like we don't really go into that. So I think that's kind of the difference.
Yeah, that makes sense. So you've been doing a lot of stuff at Spotify with recommender systems. You're working on a few different ones, but is it safe to say that all the new music that I've found recently on Spotify is in part because of the work that you've been doing?
Wow, I can take some of the credit, but not all, right? Like there's just so many teams working on it. So yeah, I think it's a lot of amazing people on this problem, all kind of.
And where's your special sauce? Are you working mainly on the platform, on the models, on the optimization?
Yeah, so I work as a senior machine learning engineer in personalization. So kind of my focus has been quite a bit on user understanding. So like how do we actually understand users in a way that helps out everyone basically in the company, like in terms of the models. So more on models, some ML, like obviously doing a lot of MLOps because otherwise you can't ship anything, right?
Yep.
And then evaluations also, a lot of evaluations.
Yeah. I imagine you're playing with features, you're knee deep in features, and that's probably your day in, day out.
Yeah, for sure.
Any features that surprised you that have a whole lot of weight you would have never expected?
I think one of them is, say, an account age, which is very interesting. So account age basically is like how old is an user, right? And we have seen interesting patterns. Like you wouldn't expect like people who have been on Spotify longer have certain kinds of patterns than the new users, right? So there are like very interesting patterns there.
Is it because of the UI features that you feel like the account is different, or the account age makes a difference when it comes to features?
Yeah, that's a fair. I mean, see, so I'm just giving an example of one model, right? So there we have like dozens of models. So every model works differently, right? I mean, and so on. So features are unique to the models. But so speaking to your question, like I think some of the older users may have certain habits, right? Some of the newer users may be getting onboarded due to podcasts, for example. Some of the older users may have joined because of music, right? So they have certain kind of habits which is ingrained, and it's hard to change people's habits and so on. So, there are those kind of correlations also, right? And we recently launched audiobooks, so, that's another thing, so all of those things play a role, yeah.
Yeah, I've been loving the audiobooks, by the way. So there are some really interesting problems that you face though, right? Like one being cold start and how you can recommend something to somebody who is first joining Spotify, which feels a little bit like that's probably the minority, I would imagine, because we've all used Spotify in one way, shape, or form by now. I would assume, but potentially no. You have better ideas on that. And so how do you deal with the cold start problem?
Yep. So cold start is a very important problem, right? And there are two main reasons why I think cold start is very difficult to solve in RecSys. I think listeners who are from e-commerce would relate with what I'm going to say, right? So one is that you don't have any history. That makes intuitive sense. Like you just don't know anything about the user, right? And the second, less intuitive reason is because of how the systems are managed, right? So we have usually batch systems. So these systems kind of operate, maybe they infer like once a day for all of users, and they're running behind, right? Like we have like almost like 600 million plus users now. So it takes a while for us to like churn through all of them. And, there are so many like dependencies and systems. So it can take like 1 or 2 days for systems to kind of actually catch up actually, right? So someone new joins in, we don't know anything about them. That's bad, but you can't do much about it. But our systems ourselves, as the person starts engaging, are also slow, right? So we take about 2-3 days to respond to it, right? So there are both of these problems which kind of make a massive difference in cold start.
And so what do you do?
Yep. So let's solve the second problem first, right? So which is, because it's controllable by us, is to do a more like near real-time systems. So someone joins on Spotify, they start listening to something, like say 80s rock, right? And then our systems are like in minutes, they respond and they kind of create new user taste profiles and like these new embeddings for them. And then those embeddings can then be used across the company, right? By all the models. So that's kind of the systematic aspect, which is like go from batch to near real time or real time, right? But then for the first problem, we have this thing called taste onboarding, where you kind of select, I don't know if you remember doing that, but you can select 3 artists or 4 artists when you sign up, and then you can also select languages and so on. So it's about kind of smartly using that information when it's available, right? So it's kind of combination of both of these things.
So then you have a bit more information about someone. You mentioned that there are a lot of models that you're playing with. I am understanding that as there's a lot of models in the whole recommender system.
Yes, there are a lot of models in the recommender systems, right? So just an example, right? Like search would have their own model, right? And then the home is going to have a different model. We have models that do ads, which are different models. We have Discover Weekly, which would be a different model. We would have, like, as I said, like what are the next 10 songs that's more of a candidate generation thing. That's another thing. Then we have multiple systems and people. So it's a very like, even as a company, like there are obviously going to be a lot of people, teams, and dependencies.
Now talk to me about, because this is just for my own, scratching my own itch.
Yeah.
When I say go to radio for any song, is that a new model also?
It's going to be a different kind of teams managing that. But a lot of them actually tend to use the embeddings, right? So the team I was working on is building kind of embeddings, and the commonality between all of that is the embeddings, right? And that's what I call as foundational embeddings. Because the goal here is to not have every team do everything from scratch, right? Like the user is the same. So if it's Demetrius, like it's the same user. We don't want teams to interpret you differently across the whole stack, right? Like we want teams to have a unified and a common understanding of you, right? So just to give an example, right? Say you wake up in the morning and you listen to some music, and then you jump onto a car, you might be listening to a podcast, and then you hit the gym, you're going to be listening to some high energy music. So those are some of the patterns that can be used across, right? It's not just one team, right? So as a user, you want to experience unified and a common thing, and like these embeddings kind of help that. So there is this embedding layer in between which kind of branches out across all these models.
Okay, so it feels like getting the embeddings right,
yes,
is one of the most important things.
I think so. I think that play a massive role, especially for candidate generation, right? Because we were talking about vector databases, right? How would you, so we have 100 million plus items in our catalog. How would you take an item and bring back 100 out of 100 million? Like that's a very, very tough problem for any ML model to do. So you need some kind of candidate generation. right? So that's basically the retrieval problem, and that typically is solved by embeddings.
So one thing that does come up quite a bit, even in RAG, is how you evaluate the retrieval. And so what are you doing to make sure that what you are retrieving is the best out of those 100 million? Did you say 100 million songs or 100 billion songs? How many?
100 million items, right? So it's a mix of podcasts, music, audiobooks, everything, right? That's a lot, right? That's a lot of items to kind of... And that's why evaluations play such a major role. So personally, as an engineer, like I have spent more time evaluating systems than even like building the model, right? Like I take the evaluations very seriously. And it's a very hard problem, right? It's like sometimes you need models to evaluate a model.
Yeah.
Right. So let me give an example, I think, to answer your question, right? So you said, how would you know those 10 songs are correct, right? So that's one model that got the 10, right? Now you need maybe, say, another model that is going to like rank or test that, right? Like, so you're going to see out of the 10, which ones are you likely to play next, right? Or play in the next 4 hours or 7 days or whatever. And we kind of take an intersection of what you would have actually, what you have been listening with that one, and then we kind of do intersections over that. So those are the kind of things we do to kind of evaluate some of the systems.
Now, you mentioned as an engineer, you've spent more time working on evaluation than even building the models, right? What does your time working on the evaluation system look like?
When I'm talking about evaluations, I'm talking about evaluating embeddings. Okay, so let me be clear there. Because there are teams that do classification models where the evaluations are going to be not as difficult, right? So, I mean, that's going to be classic precision, recall, whatever, right? As long as you've set up the labels correctly, you can get kind of pretty far with just the basic metrics. So I'm talking about these embeddings, right? And in the LLM land, those embeddings may be coming from, say, text embedding 3 large model from OpenAI or whatever, where you parse in a text and you get back embedding, right? So those are the embeddings I'm talking about. And these are they're very abstract, right? Like you can't look at no human can look at an embedding and say like, okay, that's good or bad, basically, right? Like you can't do it, right? So now you need...
it's computer language.
It's a computer language, exactly. It's numbers. And these numbers kind of have these non-linear relationships with each other, right? So in terms of evaluations, we kind of break it down into more like sub-facets, right? So one is intrinsic evaluations, right? So we take these embeddings sitting in the vector space, and we say like, okay, so we have a Demetrios embedding, right? Like what are the 50 users similar to Demetrios? Right? So we do the nearest neighbor lookup on that embedding. We get back like 50 users. So it may be, say, me, 49 other people. And then we have some kind of heuristical system, which is going to be like, okay, Demetrios likes podcasts, mostly podcasts, and it's a user in US.
Know me well. Have you been looking at my embedding?
No. We can't really look at anyone's. But
I'm just too easy to understand.
I'm just guessing, just a guess. But based on those heuristics and matching, we are able to then say, okay, I think our embedding is not bad, right? It's able to catch like 30% of what we thought Demetrios' similar users look like. So these are the kind of like intrinsic evals I'm talking about. Then we'd also do extrinsic evals, which would take the embeddings into other models. So you build these mock models, which kind of mock some aspect of Spotify, right? So as I talked about predicting future listens. So you would actually, what you would do is you take Demetrios' embedding and then you put it into a system and say like, what would Demetrios listen to in the next 7 days, right? So, and then you kind of see the actual listening and you kind of do overlaps of that. So you're kind of like really figuring out if embedding is actually good, is even doing its job, right? And like that, like you build these basically mock downstream models and you try to like evaluate these embeddings by passing through those models. So you convert evaluating embeddings into a classification problem, essentially.
Yeah.
That's kind of what I'm saying.
So you're trying to predict and you don't actually do anything. You're just putting that side by side with my real actions. And you're seeing how well you were able to predict that.
Yep. If that makes sense, right? Because embedding itself, you can't do, as I said, it's hard, right? But then you can feed it into these systems, right? And these systems are now classification or regression systems, which we know from all our love with classical ML, right? Like those are, if they are classic techniques, you can easily evaluate them. through ROC, AUC, precision recall curves, and so on. And then when you feed them into those, you can evaluate the downstream systems. So you're not evaluating the embeddings yet, you're just evaluating the downstream systems. And if they improve, you can basically say embeddings are doing better.
Sure.
So it's a two-stage process, which is what makes it an incredible problem, right? And it's very hard to tell people okay, so you're now building embeddings, and then you have to evaluate with these mock models, which are there. So yeah, there's a lot going on there.
And how are you able to test this stuff out easily? It feels like there's a lot of infrastructure in place to be able to support that.
So we have internal platform teams that kind of help with a number of things. And yeah, so it's a whole stack of distributed systems like cloud data flow, Bigtable. We use Kubeflow. So all of those kind of things kind of play a role there. So a lot of the engineers' time obviously is also not just in coming up with an idea, but also productionizing it in these systems.
Didn't one of these pipeline tools come out of Spotify way back when, was it Luigi or something? Yes. Is that still in use?
No. Yep. My team actively used it, but yeah, I know a lot of teams are now maybe moving to more modern tools. But yeah, love Luigi.
Yeah, really? Oh, that's awesome. That's great. And so it does feel like there are other ways to do this. What are different approaches if you didn't use this? And correct me if I'm wrong, the style that you would call this is transfer learning?
Yep. So the transfer learning, exactly. Again, let me take an analogy of LLMs, right? I think that will help here. So OpenAI comes up with a new embedding model, right? And then they create these foundational embeddings. But then you work in a finance company, or say you are in a law firm and you're analyzing a lot of these law texts, or like tax docs or whatever. So you might want to fine tune them on your data, right? So that's basically transfer learning, right? So you're kind of tuning the underlying model, you're not changing it. And that's kind of the same approach we take here, where we build kind of these foundational embeddings. So our team would build these representation learning based models to build the embeddings. And then all of the downstream teams would, on their own task, tune them, essentially.
Oh.
So when you're talking about personalized DJ, they would maybe take the embedding and then they would tune it in the voice arena, voice setting, what works, what doesn't work. A search team would then instead look at search features. So what are you likely to search? And they would still use the same embedding, they're just tuning it in their own models, basically. That's kind of the approach of transfer learning.
Are there ways that you think this could also work at Spotify without using transfer learning?
Everything has an alternate, right? Something used to be done, right? So now
yes.
So the alternate is don't use embeddings, just kind of build everything from scratch, right? So we look at last N days of history of a user. We look at what devices the user uses, the country, the listening, and every team starts to do everything from scratch, and you don't use any embeddings. You don't fine tune anything. So again, analogy to LLMs is the financial company builds their own LLM from scratch. They don't touch OpenAI, they don't touch Llama or whatever. They just build the whole encoder, decoder, transformer. It's possible, right? It's not impossible. Yeah. I mean, you can still do it, but the amount of difficulty you might need to put in 50 engineers for 6 months to build that, right?
Sounds expensive.
Yeah, it's expensive, right? And GPU costs and so on. So you just use someone else's learning and you transfer it to your own task, right? That's kind of where a lot of the secret sauce and magic happens.
So you're constantly updating me as a user in the embedding database or the vector database. And where do features come in?
Yes. So features come in during inference, right? So we train the model, right? And say I'm okay, Dimitrios has started listening to jazz. And I want to update.
You know me too well, man. What is going on?
Wow, that's great, man. Okay. I haven't looked at your
Bill Evans, and I am stoked. On a Saturday afternoon, my day is made. Anyways, I started listening to jazz, yeah.
Yes, and our system is going to be okay, let's trigger an inference for Dimitrios, right? And when you trigger an inference, you're going to be okay, so let's build the feature set for Dimitrios, right? So then those features may be, say, demographics. They may be what have you been listening in the last 6 months? What have you been listening over the last 28 days? what have you been listening in the last week? So you have these different time frames, and jazz kind of comes into the mix basically, like, right? So then you update the representation. So you're not like moving that embedding extremely, like we just forget everything you've heard in the last 6 months and we just make it like a jazz thing. But we just want to like dilute it a little bit. We're like, okay, let's just take like Dimitrios's like pop and like rock taste and just put in a tinge of jazz onto it, right? And if Dimitrios starts enjoying jazz like quite a bit, like we will expand jazz in that taste and we'll remove some other things, right? So that's kind of how it continues to update. Yeah.
And do you have a weight on what I'm listening to right now versus what I listened to 6 months ago or 6 years ago? Because I've been on Spotify for a while, right? So how can you balance all of that music? I know there are sometimes that I'll see on the UI, something will pop up and it'll say like an old classic or something. I can't remember the exact words, but it's kind of like, you used to like this. Do you still like it, kind of thing? And you want to jump back in and listen to it?
No, that's a good. So, I mean, those are again some teams that may be like looking at raw data and doing that, right? But in terms of like the taste profile and embeddings, we do have certain factors where we take some of the time, but we let the models decide it, right? So if you kind of are being very active and listening to something from 5 years back, like our model will weigh that higher automatically, right? Otherwise, we're going to be, by default, we're weighing the recent more than not, basically.
All right, real quick, let's talk for a minute about our sponsors of this episode, making it all happen, LatticeFlow AI. Are you grappling with stagnant model performance? Gartner reveals a staggering statistic that 85% of models never make it into production. Why? Well, reasons can include poor data quality, labeling issues, overfitting, underfitting, and more. But the real challenge lies in uncovering blind spots that lurk around until models hit production. Even with an impressive aggregate performance of 90%, models can plateau. Sadly, many companies optimize for prioritizing model performance for perfect scenarios while leaving safety as an afterthought. Introducing LatticeFlow AI, the pioneer in delivering robust and reliable AI models at scale. They are here to help you mitigate these risks head on during the AI development stage, preventing any unwanted surprises in the real world. Their platform empowers your data scientists and ML engineers to systematically pinpoint and rectify data and model errors, enhancing predictive performance at scale. With LatticeFlow AI, you can accelerate time to production with reliable and trustworthy models at scale. Don't let your models stall. Visit LatticeFlow.ai and book a call with the folks over there right now. Let them know you heard about it from the MLOps Community Podcast. Let's get back into the show.
One thing that is fascinating, though, is thinking about those people that are like me. And you mentioned there's over 100 million different items. Does that include people? Because I would imagine you said there's 600 million users of the app?
The 600 million MAUs worldwide, yeah.
So yeah, I'm just wondering, like, there's got to be a ton of people that are very much like me. I think I'm a special snowflake, but if I look in your vector database, I'm going to find a whole lot of people.
That's the beauty of embeddings, right? Like everyone is a snowflake, right? No one person is going to get the same embedding. So that's kind of so special, right?
Yeah, that is very true. And so then as you're looking at these different embeddings and you're looking at ways to make it better in the future, what are things that you're focusing on?
Yeah, few things, right? One is definitely feature spaces. So like, how do we better represent a user, right? So so for now, we have been focusing a lot on the music side, right? So we have a musical embedding and then we have podcast embedding and so on. But like you can imagine like a cross-content kind of embedding where we take Dimitrios's podcast listens along with music, right? So you may be listening to jazz on a day when you listen to, say, like a history of music podcast, whatever, right? So there may be some correlations there, which are actually very difficult to find algorithmically. So to do that, like we need to combine your podcast music and all of that taste together and pack it together. That's definitely like one aspect of improvement. Another one is how fast we respond, right? So you listen to something and we like bang, like we respond immediately, and all of your Spotify is updating immediately after that. So I think the two things I mentioned, it's itself a very tough problem, and it takes, I think I would say, several months or even years.
Yeah. How hard is it to shift from the batch, like you said, it was like a 1 to 2 day batch type recommendation cycle, to going to that time cycle?
Yep. Fascinating thing, right? The way I see it is that there is a Goldilocks zone with how often you infer, right? So I call it Goldilocks zone, basically, right? It's like, I think a lot of people think it's either batch or real time, right? But actually, I think there may be something in the middle, which is near real time. So by near real time, it basically means that you don't need to infer for Dimitrios when you start listening to jazz in like 30 milliseconds, right? Like we don't like, your Spotify listening would not like dramatically switch in like less than a second, right? Like that's unlikely, right? So
Yeah.
you can like put that jazz listen in a queue along with like some other people, and like as the systems like process that, so it can take like a few minutes, right? But 1 or 2 minutes is acceptable latency there, right? So that's kind of what I say, like Goldilocks is, it's a good trade-off between like being responsive, but at the same time, like you're not blowing up. Otherwise, like your engineering systems have to like scale up to like massive scales, and then your whole on-call burdens, you need to put in like, I don't know how many SREs, and like you have to do like all kinds of stuff to make that a reality, right? So I think that's kind of the dream, is to train as less as possible, but infer as much as possible, but not in real time. That's kind of how I see this thing play out.
So if I understand it correctly too, it's that every time you want to update, so the closer you get to real time or near real time, that means that you have to create new embeddings each time.
Yep. And let me just give a little bit, just to break this nuance a little bit, right? Okay. So our systems are fast, right? They're still like the serving is all real time. Serving cannot be like, you can't wait around 2 minutes to get back the 10 listens, right? Like what I said. So it all has to be in 30 milliseconds, right? So I mean, just want to be clear there, right? So that's kind of the final layer, right? But the question is that online store, that feature store that is online, that is serving those recommendations, how fast is that being updated?
Yeah.
Right. So you have like we understand Dimitrios, but that understanding may be of 3 days back, right? So whatever you were doing on Spotify 3 days back is what our understanding is at this moment. That's what I say. That's still being served very fast. Like we still are serving that at 30 milliseconds, but it's still serving things that we know about Dimitrios 3 days back, right? So that is a batch features in online store. That's what I mean by that, right? It's still batch systems because your understanding is behind, but you're still in online. The question is to move your understanding, your features, as much as closer to real time as possible, right? So it's you want to move it to a level where it's like a few minutes lagging features serving in 50 milliseconds. So near real time inference served with real time systems, if that makes kind of sense, basically.
It's very clear now, 100%. So you have an understanding of me that's 3 days old. And so whatever, I really like that put it into perspective, because now I see that, okay, whatever I do today, it's going to be reflected on my Spotify recommendations in 3 days.
Yes.
And so one other thing that I was thinking about is that the vector database that you have, is it just one gigantic database that everything goes into? Because you were saying that you want to be able to have any team, any ML team, any recommendation team play off of it, or is it a bunch of different ones depending on the location or whatever it is? Like, how's the system look?
I mean, we leverage a lot of Bigtable, which is essentially a Google Cloud product, amazing product. And we have like multiple different vector databases for like different purposes. But for, say, like tracks, it would be like one vector database, because we want to keep all of that 100 million items or whatever that may be, right? Whatever we want to surface, like in one vector database, and then we do nearest neighbor lookups on that, essentially.
Okay. And then you know which ones to go for, depending on what the use case is.
Exactly. Yep. So that's kind of, and we have to scale it quite a bit, as you can imagine, like all of the auto scaling, and it's a very, very complex system, like just to get that to function, like so that like you see no difference basically. As a user, you perceive nothing is what our goal is, and that takes tremendous amount of effort. So I do want to shout out to all my team members in that regard.
Yes. Give them a huge shout out.
Yes.
So correct me where I'm wrong. I'm going to try and break down the cycle here. And you tell me where I'm not understanding it. I go on to Spotify. I play my Bill Evans and Chet Baker jazz playlist that I absolutely love. And this is the first time that I'm playing it on Spotify. I haven't played it on Spotify because I didn't realize it was on there, and I've always been playing it on YouTube. And now I play it, and it's like, oh, new information about Demetrius. That information gets taken and it gets put into an embedding model to update my embedding. And so you're constantly gathering information about me, and if there's new things or whatever the information is, you're just adding a little bit to my embedding, which is your understanding of me as a user. And once that embedding is there, then it goes and it's able to feed that information and that description to the online feature store and be able to serve everything very quickly, so that in a few days after I listen to my Bill Evans playlist, I now am starting to see more cool, great live Bill Evans tracks that I had never heard. And it's coming up maybe on sometimes I'll let the Spotify just play and it will come up with random songs. And so it'll be spiced in there, and then I give it a like, and now there's like more signals that, oh, actually, he's really getting into jazz, and it gets reincorporated in. Where I think I'm losing, or I'm not so clear on, is how does the embedding and the vector store go to the feature store? And like that pipeline or that route, what does it take and how does that look?
So you said like you listen to that playlist that you had heard on YouTube, and then you come on Spotify and listen. So our goal is to not take those 5 days or 3 or whatever the end days to respond. We want to respond ASAP, right? I think we are clear on that, right? So that's kind of the goal of this new model, is like we update like ASAP, right? Or rather, like I should not say ASAP, like to be technically correct, like few minutes, right? So we want to respond in a few minutes. Now, your question was, how does vector database and feature stores kind of connect with each other? So it's actually like, it's very it's kind of one and the same when you're talking in the online setting, right? Because a lot of the times teams don't care about embeddings, right? Teams want to know in a RAG system, like a person will not care about what the embedding is, right? They want to know the documents, right? What are the nearest documents? Same thing applies here, right? Teams don't personally care what the embedding value is. So they call the vector database, which you can say is like an online feature store, because they're just calling that and then getting back those documents or tracks, basically, right? So they don't really care as much about the raw embeddings when we're talking about these candidate generation cases. Now, there is a second use case, which is aligned to more what you were saying, is say a team is doing ranking, right? And that ranking is where like you might feed in demographics and like, are you a podcast listener? So there they fetch the raw embedding from our vector database. So that's why I'm like mixing the words. So it's in candidate generation, it's vector database. In a ranking setting, it's a feature store. They're one and the same thing. I mean, if that makes sense.
Oh, interesting.
Yeah.
Okay.
I mean, it's a little nuanced, right? But because the ranking team is building their own models, there they care about the real values of embedding.
Yeah.
Like they want the real value of the embedding. Demetrius is like whatever, like 128 or 256 dimensional embedding. And that goes into their model, which would then infer, okay, right? Like I think when you search for Q, is it like Queen or is it like some other artist, right?
Yeah.
So there, like in that search model, like your raw embedding matters. But when we're talking about the bad habits and Shivers example, like there the raw embedding does not matter. You just want those 200 candidates or 200 tracks back, right? That's a more vector database analogy, and in the ranking, it's a more online feature store analogy. I don't know if that helps.
Yeah, I like it. It separates it very much because I was under the impression that it would be like, okay, cool. Vector database now goes to the feature store, or the embedding now goes to the feature store. But it's more like, no, the feature store is kind of doing what the vector database does. And so there's a little bit of overlap there. And you still need the embedding, but it's not like you need the embedding when you're doing the different use cases. And so what I think about then is feature stores are very much known for being this power up when you need like real time, right? And when you're doing that very, very fast inference. Does your use cases with these embeddings and trying to get the embeddings out and the candidate generation, like, how do you make sure that is fast on inference? Because is that still like, you're still having to go up against whatever 50 milliseconds inference time, right?
Yep. So we keep everything in these fast online stores, which are super fast, 50 milliseconds, right? And we update them in the backend. That can be 1 day, 2 day, 3 day, or that can be a few minutes, right? So, but we still need some notion of Demetrios in that online store so that the search model can call that in 50 milliseconds, essentially, right? Are they getting the best version of Demetrios they can? Maybe not, right? They are still getting a couple of days behind, but in majority of cases, that's fine, right? Even 2 days behind is not such a bad, like it's fine, like for maybe 90% of the systems, they don't really care, right? Like they're like, oh yeah, Q would mean Queen for Demetrios and not like some other artist starting with Q. Like that thing, to be honest, is going to be very similar for you, right? Like, but for another team, say that is building out the home shelves, they really care about up to date, because if you started listening to jazz, you better want to see jazz there.
Yeah.
Right? You want to see jazz like right up on the home screen. And that team cares about it being updated fast. So it's really is again very nuanced. Like which team, what is the use case, and how fast they want to be updated, these embeddings.
And so the next step on this journey feels very much like, how are you informed at how your product is going to be used within the Spotify app? Because it feels like the whole way you go about creating the product would change depending on where you're going to sit within the app.
Exactly. It's like so many different use cases and complexities. I think that's where we were talking about evaluations, right? When you want to make a generalized foundational embedding, you have to cover like so many cases. How do you even evaluate that, right? We can't predict how is it going to be used, right? So that's why, like, as I said, like evaluating these systems sometimes is harder than even building them, right? Because not everyone can, I said you can just fine tune, but not everyone can fine tune. Not all teams have the capacity or ability or desire to fine tune. They're like, I'm just going to use your product. If it's good, we'll use it, otherwise not. Now, you really have to step up and like build embeddings that can do something for everyone, right? And that's where like doing something for everyone in ML, like how difficult that is, essentially.
Exactly. Like it wasn't hard enough already.
Yes.
You've got 3 teams that you're servicing and they all want you to go in different directions.
Yes.
What are some of these different pools? So I guess the way that it works within Spotify on the organizational level is that you're creating this product and then the UI or UX teams come to you, or do you have UI, UX people embedded in your team to help you and guide you with how it would be used? And I would imagine also the product managers are helping along that.
I don't personally work with UI, UX as much because a lot of these systems are ML systems create candidates that can basically be a black box. So for a UI, UX person, it's going to be like, okay, we will get like 10 tracks. How are they created? We don't care. right? So that's like all of this ML that we talked about in this show, right?
Yeah.
So for the UI UX person, it's again a black box. They don't technically need to care about it. They only care about, okay, once we know the 10 tracks, how is the best layout? Do we allow Demetrius to skip past it? Do we allow Demetrius to like swipe up and add to playlist? So there's a lot of those like UI UX elements that you actually interact with. But
Sure.
the way we play a role in that is through feature collection, right? So like sometimes we, as ML practitioners, we want to know if Demetrius is, say, skipping past some of those things in radio or not. And that is
Yeah.
something we want to get logged and things, and then we use those logs in our models. That's kind of where I see the loop. So it's going more from UI UX to ML rather than the other way, if that makes sense. So it's all features. It's all kind of interconnected.
Wow. So I'm trying to figure out where to go next, because this is so cool to think about how you're basically just saying, hey, here's what you get. If it's valid, take it, go have fun, plug it into the app. And if not, maybe request something else, or it's probably not for you. Go ask another team.
Something like that. I mean, it's more nuanced, but yeah, something like that.
Yeah. Okay. And it does feel like there are constantly new features that are coming up that you could potentially want to track. Like I know that there is the playlist where you can kind of tune into a playlist by swiping through it and just hearing 30 seconds of a song.
Huh.
How do you stay up to date with, all right, there's this new feature that's going to be rolled out across the app. Now you can incorporate this into your fine-tuning methods.
Yeah, fantastic question. Yeah, we have some amazing data engineers and data scientists. So we typically start this process at data science level, right? So instead of incorporating a new fancy feature like right away, because you know how difficult productionization is, right? We first, I mean, the way that, at least my philosophy personally, is to first use those features in evaluations. What you could do is, say, a fancy new audiobook thing is coming out, you could just use that feature to build a cohort, right? So you would say, okay, we have been evaluating embeddings on podcast listeners, music listeners. How about audiobook? And we use kind of those audiobook features in that evaluation. And if we gain confidence in these kind of notebooky environments and with analytics and A/B testing kind of situations, then you know, okay, this feature is not bad. Like, you know, this feature is pretty good. And, you know, like it's helping us. If it's helping us move our metrics in the evaluation land, maybe it will help our model. We bring it back, right? So will not like typically jump onto anything new and fancy unless it's really, really cool. So that's kind of how I see it kind of play out. Like, yeah.
And are the main metrics you're looking at right now what you were talking about with speed and relevance?
Yep. Relevance is definitely one of them. So it would be like essentially like things like relevance, accuracy, like all those things, but also like we have these ranking metrics, right? So like imagine like you have home like where there are like multiple shelves. This is a ranking problem, right? Where like which one are you clicking or which one are you engaging with, right? So that's where like things like MRR and NDCG come into play. But yeah, you could say that that's some form of relevance. That's more of a ranking relevance.
Yeah. And that's also where that twin or that prediction simulation comes in, where you get to say, let's see if we do this or if we show these or whatever. Let's pretend like we're going to simulate out what Dimitri's going to do for the next 3 days, 5 days.
Exactly.
And then I throw you a curveball and I listen to Gregorian chants and you go, whoa, I was not expecting that from this guy.
Yes, exactly. Yeah. But some of our discovery teams will be very happy, right? They will be like, okay, Demetrius has discovered something new. Like, can we update Discover Weekly now? Because Discover Weekly like follows you, but then they want to give you something you've never heard before, right? So they really they love it. Okay, now you've heard this something new genre. Like, let's pick on that and like start showing you. So, but some other team is going to be unhappy. Some other so it's it's kind of how like all these different systems interplay and work together to kind of satisfy the user, basically. Yeah.
Man, it's been awesome talking to you. I really appreciate how transparent you are in all of this stuff that you're working on. It sounds like a really hairy question when it comes to evaluating this, keeping it fast, but also making sure that what you're getting is up to date and it is interesting for the user is very fun.
Yep, absolutely. Fun stuff.
Right on, man. Well, this has been a pleasure. Thanks for coming on here.
Thank you so much for inviting me. Pleasure.